This lesson is over surface area for pyramids and cones. So we just did the surface area for prisms and cylinders. Now we're shifting gears to pyramids and cones. So the objective, students will find the surface area of various pyramids with regular bases and cones. So this is the formula for the surface area of a the surface area of a pyramid. It is the capital B is still the area of the base. The capital P is still the perimeter of the base. Now the L is called the slant height. Now the slant height, if you look at this picture over here, it's the height that goes from this edge up to the top. The actual height would go down to be perpendicular to the base, so it hit kind of in the center of the base right here, and it'd be perpendicular to that base kind of in the center. But the slant height, again, it's along the edge. So it says perpendicular to an edge. This is the edge I was talking about. So that's the slant height. And that's going to be where it's going to get a little bit difficult later, where we might have to find that, and that means we might have to use the Pythagorean theorem. So kind of same thing we did before. Now, one thing I want to talk about before I move on is this really only works with regular pyramids. And what that means is if the bottom is a square where all the sides are the same, if the bottom is a equilateral triangle, all the sides are the same, or a pentagon where all the sides are the same, or a hexagon where all the sides are the same, the sides all have to be the same. If not, there is other ways to do it that are more complicated. Basically, you could also find the area of every single side, so the area of that triangle, this triangle, then the back triangle, then the area of the bottom, and add all those together, but that would be a mess, so we're not going to worry about those. So, very similar to the steps on the last one, I just added one step in there. This is step 4, find the slant height. But same as before, find the base and what shape it is. Use the formulas to find the area of the base. Find the perimeter of the base. Find the slant height. If it's not given, sometimes it is given. And then plug it into the formula. So again, it's one more step from what we did before, and that's finding that slant height. So let's find the surface area of this pyramid. So the bottom, the base is a square. And again, we won't have any where the base is a rectangle because all the sides have to be congruent to be able to use this formula. So the square, you could either use, for the base area, you could either use length times width, or you could use the side length squared. It's going to be both the same since it's a square. So the base area is 5 squared, which is 25 centimeters squared. The next one, we need to find the perimeter of the base. Well, the perimeter is the sides added together. Again, you could also take 5 times 4, if you remember that formula for the perimeter of a square. Now, step 4 is the slant height. Now, again, if you look at the 9.3, that is the slant height. They give it to us, and it's because it's perpendicular right here to this side. It's perpendicular to the side, not directly in the center of that. So they give us the slant height. That makes it a lot easier. That's just 9.3 centimeters. Now we plug all those numbers into our formula. So the surface area is the base area plus 1/2 the perimeter times the slant height. So the base area we just said was 25. 1/2 the perimeter is 20 times the slant height is 9.3. If you want to type that in your calculator exactly how you see it, you're more than welcome to. 25 plus 0.5 times 20 times 9.3. It would give you the right answer. I like to do it in 2 steps where I do the second part in my calculator first. 0.5 times 20 times 9.3 is 93. So 25 times 93 is 2,325 centimeters squared. So moving on to the next one. So this one, same thing. The base is a square. So we have the base area is 11 squared, which is 121. Then we have the perimeter is 4 times 11. Again, you could also take 11 plus 11, 4 different times. Then this is where it's going to be a little bit more difficult. The slant height, they don't give us the slant height. Notice how that just goes into the center. It doesn't go to an edge. So that's the actual height of the pyramid. That's how tall it would be. We're looking for how tall it would be around this edge right here, and that's going to be perpendicular to that edge. Now, it doesn't have to be specifically that edge. It can be any 4 of those edges. That's fine. Oops. So again, I'm going to kind of look at this triangle. I'm going to redraw that so it's less busy. So the triangle I just put in there should look like this. This is the slant height that we're looking for. This is the actual height that is perpendicular to the base. So that's 12. Then this distance right here, it doesn't tell us that, but this 11, if it goes right in the center here, it's going to be half of that. So that's going to end up being 5.5. If in doubt, take one of those side lengths and cut it in half, because that's going to help for this a lot. And again, make sure you realize that this 90-degree angle that I put in, this 90-degree angle, is 90 degrees from this edge, not from the base. So this is not 90 degrees. Maybe you weren't thinking that, but just in case I wanted to say that. So from here, now it's just Pythagorean theorem. This is something that, again, you guys should be pretty decent at by now. That is 30.25 is equal to L squared. 113.75 is equal to L squared. And last step, take the square root of both of those, is 10.67. So it's 10.67. So again, just like I said in the other problems in the last lesson, I personally think that's the hardest part, using the Pythagorean theorem for that. But once you have all that, now again, you just plug it in. Surface area is the base area plus 1/2 the perimeter times the slant height, 10.67. Again, if you want to type that in your calculator, you can, but I like to do it in these 2 steps. Add those together, then we get 355.74 centimeters squared. So next, I want you to do this one on your own. Notice right away when you look at it, the slant height is given to us. That's this one. Now, the other thing they give you is this part, that is the height of the triangle. You need that to find the base height, because that is a triangular pyramid, so the base is a triangle. So when you take the test, if you don't want to actually take all these steps and write out 5 steps and 5 numbers, you don't have to, but I think it's a really good way to stay organized. So I like to do that, keeps everything nice and neat. The base is a triangle for this one. Spelled wrong, but that's okay. Forgot the A in there. And remember, the area of the base is 1/2 base times height. And again, realize, just like I said, the base area has to be a regular triangle or an equilateral triangle, so all the sides are the same. So if you look at that base, it's 7, 7, 7. They give you the height right here of the triangle is 6.1. So the base area is 1/2. The base is 7. The height is 6.1. Put that in your calculator. Is 21.35. Then the perimeter, well, the perimeter again, the perimeter, you could just add the sides together, but all the sides are the same, so it's going to be, there's 3 sides, they're each 7. Whichever way you want to do it is fine. Step 4, then, we need to know what the slant height is. Again, they give it to us for this one, so that's really nice. That's that 5.4 here. And so that means in this fifth step, all we have to do is plug that in. 21.35 plus 1/2 times the perimeter is 21, times the slant height is 5.4. Is 21.35 plus 56.7 is 78.05 feet squared. So moving on to surface area of cone. Now again, this is the exact same thing as what we did before, where remember when I did prisms and then I told you that with a cone, they just plugged in the formulas to the prism formula? Well, that's what they did here. So you could, obviously, this is the area of the base. And then if you took 1/2 times the perimeter is 2 pi r times the slant height, well, the 1/2 and the 2 cancels, and that's where they get that pi times r times L. So literally, this is the same formula we were just using, except for instead of perimeter, they're putting in the circumference. So if you want to do it that way, you can. I like doing it this way because there is only 2 variables, the radius and the slant height. Now again, the slant height for this one goes to the side. If it would go straight down to the center of the circle, that would be the actual height. And that's where you're going to have to use some of the Pythagorean theorem. Just spoiler alert for the future, we will use the actual height when we deal with volumes. And so that's where sometimes you have to find the volume and the surface area. The volume uses the actual height. The surface area uses the slant height. So that's where sometimes they give us both. So for this one, we have the surface area is pi r squared. Our r for this one is 4, so pi times 4 squared, plus pi times 4 times the slant height. They give us the slant height for this one is 6. Now again, you can do this all in your calculator. It'll do all the work for you. You also could leave it in terms of pi. I would not recommend that. So for the first one, you get 50.27. The next one, you get 75.40 when you round to 2 decimal places. Add those two together. You end up getting 125.67 inches squared. That is your surface area. Now, if you wanted to leave it in terms of pi, pi times 4 squared plus pi times 4 times 6. This would be 16 pi. 4 times 6 would be 24 pi. And then just add 16 and 24 is 40 pi. So again, if you leave it in terms of pi, I personally think it's a little bit easier. But a lot of you guys aren't very familiar with it, and you're much more familiar with decimals, so this is what I would recommend. If you put this on a test, that's fine. If you put that on an exit ticket, if you leave it in terms of pi on an exit ticket and you miss it, please email me, because I didn't put that in as an answer, but if you do put it in, I want to give you credit for that. So do this one on your own, and again, the biggest thing, the hint, is that 12 is not the slant height. It goes right into the center. It's not the slant height. So if you use your formula, is pi times the radius is 5 squared plus pi times the radius, which is 5, times the slant height, and we don't know that slant height. So if you look, and you can actually kind of see the triangle they're getting at right there. We have 12 and 5, and then our slant height. So we have 12 squared plus 5 squared is equal to L squared. That's 144 plus 25 is equal to L squared. 144 plus 25 is 169. So when you take the square root of both of those, you end up getting 13 is equal to your L. So that's 13 up here. And now we can put this into our calculator. This is 78.54. Again, I like to round to 2 decimal places on this. Then we have 204.20. Add those together, 282.74 centimeters squared. Again, the other way to do it, that would be 25 pi plus 65 pi. 25 plus 65 is 90, so that's the same thing as 90 pi. I don't care which way you do it. Just make sure you're being careful. So the other thing I want to show you guys or talk about is some of these story problems. And you have a couple on the test. Maybe they're not exactly like this, but I want to get you guys thinking about that, especially with this one since it's a little bit of a shorter lesson. The biggest pyramid in Giza, Egypt, I might be saying that wrong, is around 4,500 years old. We decided to give it a facelift and paint the whole thing. Each side of the square base of the pyramid is 755. So they tell you have a square base. That helps. From the base straight up to its point is 480. So from the base straight up to the point. So that's not the slant height. So if I were going to draw a picture, that would be my base. Put my point up here somewhere. Each side of the base is 755. They're all congruent. And then the actual height straight up to the top is 480 feet. We don't know what the slant height is. If we had that slant height, we'd be in business. How much paint would we need to cover the pyramid, including the base? So if we're painting something, we want to know what the surface area is. We want to know all the paint goes on the outside. We want to know what that is. So to find the surface area, again, the first step, we know that the base is a square. Second step, the base area is 755 squared. So it's going to be a pretty big number. 570025. And the third one is the perimeter. The perimeter is 4 times 755. Is 3020. And step 4, the slant height. Again, to find the slant height, you're going to have to end up doing the Pythagorean theorem. So the actual height is 480. Then this length down here, remember, it's not the whole 755 because it goes right in the middle of that. So it's actually half of that. So 755 divided by 2 is 377.5. And then we need to find the slant height. So we have 480 squared plus 377.5 squared is equal to L squared. 480 squared, 230,400, 377.5 squared, 142,506.25. Add those together. And I know these are really big numbers, but it's just buttons in your calculator, so don't be too intimidated by that. And the last step, you're taking the square root of both sides. So put that in your calculator. You're going to be getting 610.66. So we dealt with all those big numbers. We end up getting 610.66 is not too unbelievable. So that's that slant height, 610.66. I know this looks really messy at this point, but now by this time we don't really have to mess with that. I'm going to put my step 5 over here for lack of room. So my surface area is the base area. Oh geez, I'm still not going to have enough room. Sorry to erase this, but this is where it's going to have to go. We have 570,025 plus 1/2 the perimeter, 3,020 times the slant height, 610.66. That's 570,025 plus 0.5 times 3020 times 610.66 9222096.6, and now we add those together, plus. So 1492121.6 feet squared. That is the surface area of the pyramid, including the base. So you're also painting the base of that. So if you wanted to actually paint that whole thing, you'd have to go to Menards, hopefully on an 11% rebate day, and you'd say, I need, what, 1,492,121.6 square feet of paint. So that one is a lot of big numbers, and we had to use the Pythagorean theorem. This one, for you guys to do on your own, I think is a little bit easier. Hopefully you guys have been pausing this and then trying it on your own and then hitting play, but if you haven't, make sure you're trying to do that on these you-do problems. I should have mentioned it earlier, and I forgot. But the surface area of a cone is 1,719.4. If the radius is 13, find the slant height. So the thing with this one is they give you the surface area. They're giving that to us. They're giving us the radius is 13, but they're not giving us the slant height. So remember, the surface area for a cone is pi r squared plus pi r times the slant height. So we have pi times 13 squared plus pi times 13 times, times L. We don't know what that L is. Well, to solve this, the thing that we do know is the surface area is 1719.4. 1719.4. And now we go ahead and try to solve that. So 1719.4 is equal to 13 squared times pi is 530.93. 13 times pi is 40.84 times L. And now it's just a two-step equation. So all I did was I put that in my calculator, you get 530. Then this one I put the 13 times pi in my calculator. Now you're just solving this like normal. So to get that L by itself, I need to subtract 530 first. Minus 530.93. 1188.47 is equal to 40.84 L. Divide both of these by 40.84. Divided by 40.84. Divided by 40.84. You end up getting 29.10 is the slant height. So that'd be 29.10 feet. Not feet squared, because the slant height is not an area, it's not squared, just 29.1 feet. So if you have any questions, let me know. Sorry that took a little bit longer than expected, because there was a lot of calculator stuff that I think took a little bit